Let's take a look at a problem about a normally distributed fruit situation. We've got a mean of 278 grams for this particular fruit with a standard deviation of 22. So we expect, like most fruits, 70%-ish to be within 22 grams of 278. If we look down at my picture of the normal distribution here, 278's in the middle, right? There's 0 standard deviations from the mean, and then 1 standard deviation to the left would be 256, 1 standard deviation to the right, add 22, subtract 22, would be 300. So we expect like 68-70% of these fruits to be within 256 and 300 grams. We were asked if we were to randomly choose a piece of fruit, what's the chance it'll be between 260 and 337. So I made marks to go with that. So 260 is just greater than 1 standard deviation to the left. And if you think about the empirical rule that we have, 1 standard deviation to the left should be around 34%. Now we weren't quite 1 standard deviation to the left, so maybe it's more like 30% we have in that little left side of that picture. And if you look at 337, that's just below 3 standard deviations to the right. And so I was estimating that to be about right here. And if we look at the, think about that empirical rule again, 3 standard deviations to the right, we would expect pretty much almost all of the data. So then half of the data would be from the mean to about 3 standard deviations to the right. So we're at like, I don't know, 45% if we're not getting quite to the 3rd standard deviation. So I'm just going to make a wild guess here, 30% on one side and 45 on the other. So maybe like 75% of the fruits are going to be in that range. And if we look at my sketch here, I'm trying to estimate, and I'll calculate this in a second, but I'm just trying to, and again, I can't answer these questions without drawing a picture. So if you're not drawing pictures, then you're only doing half the work. So this smoothed out histogram represents all possible fruits. And we're trying to say what percent of the fruit lives in this range right here. So of this graph here, I'm concerned about this shaded region. And notice I'm missing a little bit to the left. Right? That's not shaded. I'm missing a little bit to the right over here. So I'm estimating, based on the empirical rule, that's around 75%. All I need to do is go to some kind of normal distribution calculator to do so. And a spreadsheet's a good way to do it, or StatKey does a pretty good job of it here. So I'm going to go to StatKey, and so show desktop. And there's a link on this problem if you're playing the similar one as me for StatKey normal distribution. You just search for StatKey, theoretical, normal. We want to edit the parameters so that we have a mean of 278 and a standard deviation of 22. And then we want to mark a left tail so that 260 is in the left tail. And that's a bottom number because it's a weight of fruit as opposed to a percentile. So a fruit weight, in this case of 260, puts about 20% of fruit smaller than it. If there's 50% from the mean over 2 there, then that would leave around 30% in this half above the red area. And we want to do a right tail to set the other value, and that was 337, I believe. Better double check that, which that looks about almost 3 standard deviations. What's my problem? Yes, 337. So StatKey nicely says, well, you know, there's just a tiny bit of fruit that would be above that, so less than 1% of fruit would be above 337. And then in between these two fruit weights, we would expect 80%. I was close. I was saying 75. This says 79. Not too bad. So updating my picture here, I think that red region right there represents about 80% of the fruit. Now, the computer actually said it was 79. Maybe it should be a little more precise. 79% of the fruit was in there, or as a decimal, 0.79. All right, just some other notes. When I grabbed StatKey originally, it had a mean of 0, standard deviation of 1. That's called the standard normal. That's for z-scores. And so 0 is the mean, -1 is 1 standard deviation to the left, +1 is 1 standard deviation to the right. So for example, a fruit with a weight of 260 with this mean and standard deviation would have a z-score of about -0.8, just a little bigger than -1. And a fruit that had a weight of 337, given a mean of 287 and a standard deviation of 22, would have a z-score of about 2.7-ish, because here's a z-score of 3, and we're just under that. So z-scores just count. How many standard deviations are you to the right or the left, given the mean and standard deviation as a spread for the data. Hope you found this useful. Bye-bye.